Hello, algebra students, and welcome to Chapter 9, Section 2, Quadratic Functions. In this section, we will learn to graph quadratic functions of the form y equals ax to the second power plus bx plus c. So in this section, we're really going to talk about two things more in depth. We'll talk about the axis of symmetry and how to find the axis of symmetry, and then we'll talk more about the vertex and how to actually find a vertex when given a quadratic function. So all the functions we're talking about today are still going to be in that standard quadratic function form, ax squared plus bx plus c. So we've seen this a lot of, chapter 8, and we'll continue to see it here in chapter 9. Of course, we have our values for a, b, and c. And we're going to take a look at the b value when we're talking about the axis of symmetry. In fact, if we look at this box below, which is taken directly out of your book, to find out what the axis of symmetry is, we're going to use this little formula right here. The axis of symmetry is always a vertical line, and the equation for a vertical line is always an x equals equation. So to find any axis of symmetry for a quadratic function, we're going to let x equal the negative value of b, or the opposite value of b, divided by 2 times the value of a. All right, and also for later on in the notes, we're going to note that the x-coordinate of the vertex is also going to be that same negative b divided by 2a. But we're going to focus on the axis of symmetry first. So a couple notes about the axis of symmetry, more notes that is. It will always be a line with an x equal equation, meaning it is always going to be a vertical line. All right, just because of the way functions work, the axis of symmetry is always going to be a vertical line. So if you look at this example of a quadratic function here graphed, yes, this is a parabola. The axis of symmetry is this blue line that cuts it in half from left to right. Notice that for this blue line here, this blue line is x equals -1, or the vertical line that goes all the way down all the -1 values of x. And that's what we're going to be finding here. We're going to be finding that axis of symmetry here. To find out what that equation is, again, it's always going to be x equal, and it'll be x equal -b divided by 2a, or the opposite of the b value divided by 2a. So here's some examples. I'm not going to ask you to graph the axis of symmetry in today's U-Try, but we are going to find that equation for that line. So we have the quadratic function y equals 5x squared plus 10x plus 3. So let's identify our b's and our a's. B for this one is 10, and our a for this problem is 5. So a equals 5. So it's going to be x equals -b divided by 2a. For this problem, -b, or the opposite of b, is going to be -10. And 2 times a will be 2 times 5. A little bit simplifying here, we're going to get x equals -10 over 10. So x will have to equal -1. So that would be exactly like the axis of symmetry we saw on the previous slide. A line, a vertical line that goes down all the x equaled -1 values. So that's it for that problem. We're going to do the same thing on step B here. I'm going to identify our b and a. So b is -9. I need to make sure I take that sign. And our a is going to be 3. So the equation is x equals -b over 2a. So I'm going to take my b and flip the sign. So it's a -9 to start with. It's going to end up being a +9. And my a is 3. So this is going to be 2 times 3. So this is x equals 9 over 6. Simplify one more step. 9 over 6 is the same as 3 over 2. So my vertical line is the line x equals 3/2, or 3 over 2, meaning this line will be a vertical line that goes through all the values of 3/2, or 1.5 on the x-axis. Here's your first U-Try problem. Complete it both in your notes and in the Google form below. Next, we're going to talk about finding the vertex. The vertex, along with the axis of symmetry, lets us actually graph a true parabola. In fact, you could argue that the vertex is the most important point because that's where everything comes to either a climax for its maximum or its minimum. So because the axis of symmetry always travels through the vertex, when you find what x equals, or the equation for the axis of symmetry, you're also finding the x coordinate of the vertex. Vertex is going to have an x coordinate and a y coordinate. It's one single point. Because the vertex is an actual point, to find the y coordinate, we're going to plug in what we find for x back into the function to see what the y value will be. So quick little recap here. To find the vertex, we need to find the x coordinate and the y coordinate. To find the x coordinate, it's still the same, negative b divided by 2a. And then when we're finished with that, we're going to take that x and we'll plug it back into the function. I have it written here as notation f of negative b divided by 2a, meaning whatever we find out for x, we'll plug it back into the function and evaluate for y. So the directions say find the vertex of the following quadratic function. So when I'm finished here, I should have an ordered pair, an x coordinate and a y coordinate. So if we work on the x coordinate first, my b value equals 10 and my a value equals 5. If you haven't noticed, it's the same problems here. So if x equals negative b over 2a, we're talking about negative 10 over 2 times 5. Yes, this is the same example problem from earlier, just to show you that, hey, once we find it for the axis of symmetry, we can use that same x for our vertex. We found out this was negative 10 over a positive 10, or negative 1. So our x equals negative 1. So up here, I'm going to kind of keep track here. My ordered pair is going to have a negative 1 for an x. I'll find out what my y is here in a second. I'm going to take that negative 1 and I'm going to plug it back into the x's here to see what y equals. So this will be y equals 5 times negative 1 squared, meaning we're going to square that negative 1 first, plus 10 times negative 1 plus 3. So this will be y equals, just a little bit of solving equations here. Negative 1 squared is a positive 1. Negative 1 times negative 1. So that's going to be 5 plus 10 times a negative 1 is a negative 10 plus 3. Combining like terms here, 5 plus negative 10 is a negative 5, and a negative 5 plus 3 is a negative 2. So y equals negative 2. So that means that my coordinate, my y coordinate, is negative 2, meaning the whole vertex is negative 1, negative 2. And we're finished there. I could also say that my axis of symmetry is x equals negative 1 because I know that this x coordinate is negative 1. Right, second problem here. Same thing here. B equals negative 9 and A equals 3. This is the same function, for example, B we saw when we were finding axis of symmetry. So my x is going to equal negative B, so the opposite of negative 9 is a positive 9, over 2A. So 2 times 3, which is 6. And we found that to be 3 halves. So I'm going to go back in. Again, my ordered pair for this one. First one will be 3 over 2. We can have fractions or decimals for a coordinate. That's fine. But to find my y coordinate, I'm going to plug 3 halves into the function here. So we're going to have y equals 3 times 3 halves squared minus 9 times 3 halves minus 8. So 3 halves squared, that is 9 fourths minus, looks like we're going to have 27 halves minus 8. This would be one of your messier ones just because of the fractions. So we're going to have, looks like 27 over 4 minus 27 over 2 minus 8. Taking care of fractions real quick here. Let's see here. We're going to go ahead and use our calculator, since that'll make the fractions just a little bit easier. And so our final answer here, y is actually going to equal, if I can find my pen, y is going to equal negative 14 and 3/4. So my y coordinate is negative 14 and 3/4. One of the harder problems you'll work with just because of the fractions, but a calculator will be helpful. Second and last you try problem, complete it both in your notes and in the Google form below. Have a good day.